ways from way back way. You know that I don't play. Streets not safe, but I never run away, even when I'm away. OT, OT, there's never much love when we go OT. I pray to make it back in one piece. I pray. That's why I need a one dance. Got a Hennessy in my hand. One more time.
Next lesson in our AS level physical geography course. Today we're going to learn about glacial weathering and erosion. Erosion and weathering. Erosion is the process by which parts of the valley are broken down due to the movement of the glacier. However, weathering is the breaking down of the valley rock due to the processes involved with the properties of ice in the glacier. Both are somewhat synonymous, but they do have differences between the two of them. Erosion is more of the processes due to movement, however weathering is due to the processes involved with the actual properties of the ice in the glacier. Erosion. To begin with, we're going to look at abrasion. Now, abrasion in glaciers is exactly the same as it is in rivers. When the material inside the glacier and the ice scours and scrapes at the valley bed, bits of rock are going to fall off. Now, coarser rock scrapes and rips out. It causes striations in the glacier. Smaller materials smooth the valley rock, so instead it leaves a much smoother curve along the valley. Extremely small eroded material is called rock flour. Plucking. Plucking is when the glacier freezes onto the rock. When the glacier then moves forward, it pulls the rock off and forces it to be ripped off the walls. It mainly happens at the base and the sides of the glacier, where there's meltwater. Now, meltwater is when the glacier begins to melt, and it melts due to increased pressure. The meltwater then is going to freeze onto the glacier in colder months, and then as a result, when the glacier moves forward, it's going to pluck at the valley. Now we'll look at weathering. Frost shattering. Frost shattering is the breaking of rock as water moves into its cracks and expands as it freezes. Water can flow into a crack in the valley. So when high temperatures are present, the water has not actually frozen yet. But when temperatures fall, the water turns to ice. When it does, it's going to occupy 9% more space, and this is because of the formation of the hydrogen bonds inside ice. They naturally take up more space than they would as a liquid. So as a result, the ice expands. This causes the rock to crack because it's taking up more space, and cracked rock can collect at the bottom of the glacier as it breaks off, and it's called scree. Nivation. The hollowing of the rock is due to the presence of ice is called nivation. How it happens is that the snow accumulates over the rock. The snow then creates a small hollow due to chemical weathering and frost shattering. Chemical weathering is basically corrosion. Some of the snow may be slightly acidic, and that dissolves parts of the rock. So this causes the rock to disintegrate and form a small hollow called a nivation hollow. Here are some questions on weathering and erosion. Answer these on another sheet of paper and hide your notes so that you can't be looking at them. Pause the video to give yourself time, but hit play whenever you're ready to see the answers. Here are the answers. If you did define all three of the terms correctly, congratulations. I'd advise you to move on to the next video, which will be looking at the formations of corries, arêtes, and pyramidal peaks. As always, thanks for watching. Be free to visit the website reviselevel.co.uk or the channel for more information on your subjects. Good luck in your exams, and I'll see
on your ways from way back way. You know that.
Beautiful view of Yosemite Valley. That's Half Dome in the background. Lost Arrow Spire is way up there. This is Manganiella. 3-pitch climb that we're going to start climbing, and it's rated 5.6. And Roy's right here getting ready to belay me.
Floyd's taking off above his first protection piece on pitch 1.
Just a little ways more to go to the first belay anchor. Some beautiful crack climbing here.